Welcome to this tutorial on adding particle effects in your Java applications. Whether you're building a game, a simulation, or a graphical user interface, particle effects can add life and dynamism to your application. In this video, we'll go through the complete process of creating and integrating particle effects step by step. First, let's understand what particle effects are. In simple terms, they are small graphic objects that can be rendered on your screen to create various effects, like sparks, smoke, rain, and explosions. They are typically used in graphics programming to enhance visual presentation and make scenes more attractive or realistic. To get started, we'll need a Java development environment set up. Make sure you have JDK installed, along with your favorite IDEs such as IntelliJ IDEA, Eclipse, or NetBeans. Also, we will utilize the JavaFX library to facilitate smooth rendering of our particle effects. Now let's create a new JavaFX project. If you're using IntelliJ IDEA, follow these steps. Go to File - New Project - JavaFX Application. Select a project name and choose your JDK version. Hit Finish. Once your project is set up, let's create a new class named Particle and write our particle logic. This class will handle the properties of individual particles such as their position, velocity, and lifespan. In the particle class, we have defined the properties and methods needed for our particles. The constructor initializes the position, velocity, and lifespan of the particle. The update method moves the particle according to its velocity and decreases its lifespan. The isAlive method checks if the particle is still living. Next, we'll create a class named Particle System that will manage multiple particles. This class will be responsible for creating particles, updating their state, and rendering them on the screen. We've created the Particle System class, which consists of a list to hold particles. The emit method generates new particles at a specified location. Each particle receives a random initial velocity and lifespan. The update method is responsible for updating each particle and removing dead ones from the list. Finally, the render method draws each alive particle on the canvas. Now let's integrate our particle system with a JavaFX application. Create a new class called main that extends application. This class will set up the JavaFX stage, scene, and manage the animation loop. In the main class, we extend application and set up the JavaFX stage and scene. We create a canvas object with specified width and height. The animation timer handles the rendering loop, updating the particle system and clearing the screen on each frame. Additionally, we listen for mouse clicks to emit particles at the clicked position. It's time to run our application. You should see a black window. Click anywhere on the canvas and voila! Beautiful particles should start to appear and fade away as they exist. Now, that's a simple way to create visually interesting elements using Java. Now, let's iterate on our particle effects. We can change the shapes of our particles and modify their colors to make them more visually appealing. Let's update our particle class. In this updated particle class, we've added a color property that allows us to assign a color to each particle. We will modify the emit method in the particle system class to randomly assign colors to particles. We've modified the emit function to create particles with random colors using JavaFX's color class. Now, our particles will have a vibrant appearance. Let's also update the render method of particle system to draw each particle with its assigned color. After making these modifications, run the application again. You will now see multicolored particles bursting wherever you click. This enhances not just the aesthetics, but the overall interactivity of the application. Next, let's delve into performance. Managing a large number of particles can become tricky as the count increases. We will implement a maximum particle count to prevent lagging by modifying the emit method. By defining a maximum count, we safeguard performance. If the number of particles exceeds this limit, no new particles will be emitted. You can adjust the max_particles constant based on the capability of the target system. Finally, we can experiment with different particle lifetimes to see how long the particles last. Adjusting the lifespan can completely change the effect of your particle system. Instead of only random lifespans, let's add predetermined stages. Here, every 25th particle will have a longer lifespan compared to the rest. This creates a visual effect where some particles seem to linger longer, making your effects even more dynamic and interesting. As a next step, we could also consider implementing varying particle sizes or shapes, such as changing their dimensions based on velocity, or even introducing methods to change their shapes over time, to add to the complexity of the system. In this example, the size of each particle is dynamically calculated based on its remaining life. This creates a nice fade-out effect where particles shrink as they die. Their transition can be visually very smooth. As we conclude this tutorial, feel free to experiment further with other particle characteristics like rotation, wind effects, or gravity impact. The possibilities are endless with Java and JavaFX. Thank you for watching. If you found this video insightful, please like, share, and subscribe for more Java tutorials. Feel free to comment below with your questions or ideas for future tutorials. Happy coding!